the properties of rational functions. So this is a rational function and this is its graph. What's significant about rational functions is finding the whole if there's any, or finding the vertical asymptotes and finding the horizontal asymptotes. As you can see, the vertical asymptote seems to be x equals 2 and x equals -2, while the horizontal asymptote is equivalent to y equals 1. How do I know that? Of course, because the degrees are the same, you simply divide the numbers beside them. So 1 over 1, it's 1. Now we factor this out. We have x plus 2 and x minus 2. So x equals 2 and x equals -2 will be the horizontal and vertical asymptotes. Okay? Now, how do we find the domain of this function? Now, the domain would have to be the values of x that will hit the graph. So as you can see, it has several graphs here. It has 3, so it has 3 pieces. It's like a piecewise function. So therefore, from -infinity, you would see that your graph starts at -2 here. And because that's the vertical asymptote, so it's at x equals -2 union. Now this will be between -2 and +2. Now remember, the asymptotes do not intersect the graph, so they will not be included in the domain. So therefore, it's going to be -2 to +2, excluding both of them, because the vertical asymptotes does not intersect your graph. And then you have another part here that would be from +2 to +infinity. So that's how you look at the value of your domain. Now about the range, as you can see, the graph will be intersected from -infinity from +infinity. So it will hit the graph anywhere going in the vertical direction. Okay, now what about the y-intercept and the x-intercept? All you have to do is to dot this, and you have an x-intercept at 5, 0, and a y-intercept at 0, -5. So y-intercept is 0 and 1.25, and the x-intercept is at 5, 0. All right. Now, this has concavity down and concavity up. Let's do that. Concavity up and concavity down. Okay, let's discuss first about the concavity down. So concavity would be, what are the values of x here that makes the graph concave? So, of course, it starts from +2 and it goes to +infinity. Okay, so all the values of x here, which will make this graph concave. Now here, okay, there is no concavity here in the middle, only here and here. So this is a concavity up. So concavity up because your concave is going up. So as you can see, the values of x here, which will make your graph concave. So that will be from -2 to -infinity. Okay, I hope it's clear to you. Now, about end behavior, we're looking at the behavior of the graph to the left. So going to the left, what happens to the value of y? Okay, so the value of y is approaching the horizontal asymptote, which is actually equivalent to 1. So going to the left as x approaching -infinity, your graph is going to the is approaching +1. So this one now is from -infinity from 1. Okay, now about the end behavior, it means what happens when you go to the right side. So we're referring to this graph. So to the right side, your graph is approaching infinity. All right, to the left side, no, sorry for that. To the right side, your graph is also approaching the horizontal asymptote. It's the same. So the end behavior would be to the right is equivalent to 1. Same thing also to the left. Both of them are approaching the horizontal asymptote vertically. Now, when it comes to right-hand limit, that's different. So right-hand limit is what is happening to your graph going from the right. And as you can see, it approaches the vertical asymptote. So therefore, the right-hand limit f of x is equivalent to positive 2. While the left-hand limit means what happens to your y when your graph is going from the left and it approaches the vertical asymptote negative 2. So the left-hand limit f of x equals negative 2 when your x is approaching the right side. So as x approaches from the left, what happens to your the symbol for this is like this. It has to be like, if you have that and you have the exponent positive, that means right hand limit. Okay, this one now, this is the symbol for the left hand limit. So this one is the left hand limit. Okay, it's different when you say end behavior, that the signs for the negative is before. When it comes to the right hand limit, the signs of the positive is after. So meaning from here, what happens to the y? From here, what happens to the y? Compared to end behavior, when I go my x to the right, to the left, what happens to the y? When my x is going to the right side, what happens to the y? So that's the difference between end behavior and right hand and left hand limit.